let's start in. As part of Master Snowflake with DBT, in this session, we are going to discuss Snowflake with DBT introduction tip. Snowflake with DBT introduction, or we can say demo. So let's start understanding Snowflake and what we are going to do with the Snowflake and what is DBT and what we are going to do with the DBT tip. Okay, let me let me diagrammatically explain. Say we have different data sources. We have different data sources. Source may be file system sources, different sources. Source may be file system like CSV, JSON, CSV, JSON, XML, Parquet, etc. Okay, etc. A source may be any RDBMS like MySQL, Oracle, etc. Source may be any, any cloud file system, any cloud file system like AWS S3, Azure Blob, Google Cloud Storage, etc. Any of a cloud file system. Source may be any uh, Hadoop or Hive. Hive. Source may be any any big data like Hadoop or Hive, etc. Source may be any data warehouse like like Redshift, etc. Source may be any storage. Source may be any storage. So first, what we are going to do is we are going to implement data ingestion activity. Data ingestion activity. Let's say this is my Snowflake data warehouse. Snowflake data warehouse. Let's say this is my Snowflake data warehouse. So first what we are going to do is we are going to do data ingestion activity. Data ingestion activity. Data ingestion activity. Using this data ingestion activity, usually what we are going to do is we are going to load this data into data lake environments. We can load data into data lake environment. Data lake, like AWS S3 or Azure Blob, or GCP, Google Cloud Storage, So these kind of data lake environments. So there is a role called data ingestion. Using this data ingestion, people can load data into data lakes. From this data lakes, we will implement data ingestion activity. We will extract data and load the data into this Snowflake data warehouse environment. Snowflake data warehouse environment. Let me let me add point here. Here we have concept called external tables, external external table, or we have SnowPy, and many other different Snowflake techniques we can use, and we can move data from move data from move data from this data lakes to Snowflake data warehouse environment. This is my Snowflake data warehouse. So this is one kind of activity usually happened in real environment. This is one. So we connect using data ingestion techniques. Using data ingestion techniques, we connect different data sources. We connect different data sources. Then we move data into data lake. From data lake, we move to Snowflake data warehouse environment. This is one approach. One approach. Second approach, data ingestion tools like Python, PySpark, etc. They can directly use loading data lake, or they can directly load the data into Snowflake data warehouse. Snowflake data warehouse. Data warehouse. This is second approach. Third approach to using different Snowflake techniques, using different Snowflake techniques for loading data from different sources to Snowflake using loading techniques of Snowflake. Loading techniques of Snowflake. Snowflake provides different connectors. Using that connectors, you can connect to different sources. You can load the data into Snowflake data warehouse environment. So this is another way of extracting and loading the data into Snowflake environment, or data ingestion into Snowflake environment. Okay, so this third approach and this first approach, extracting, creating external table or SnowPy to connect different cloud file systems and loading the data. These kind of activities we can do as part of our Snowflake warehouse environment. Okay, so first we load the data into raw layer. We load the data into raw layer team. Raw layer, then stage layer, then finally target. So we load the data into raw layer. Raw layer. So data ingestion we implement using raw layer. Okay, and after that, here we are going to use different Snowflake techniques. We are going to use different Snowflake techniques to process this raw layer data. So we write SQL queries with different filter operations, or we can write procedures or functions. Then we can read this raw data. We can read this raw data. Then we can implement the transformations. Means we are going to write ETL queries. ETL queries to process this raw layer data. Temporarily, we store the results into stage layer, stage layer, and then later, once we validate stage layer, replicated data with as expected. Let's say, example, we are doing uh, transformations like city-based transformations. Example, we have complete transactions of our all branches. Let's say we have business in all over the India. So uh, we are getting data into Snowflake for all the states, all the cities. Then our requirement is we want to do data transformations based on the city-wise sales we want. Then we apply a transformation queries using Snowflake SQL techniques. Then we store that results temporarily into stage layer. And once we load the stage layer, we are going to validate whether results are generated or created as expected format or not. Then once we confirm results are generated as expected, then we are going to load this data into target layer. So finally, we are going to move data into target layer. Target. Target layer. Let's say here we write SQL queries. We write SQL queries and to perform transformations. To perform transformations using different techniques of Snowflake. Using different techniques of Snowflake. Okay, we are going to read this raw data. Then temporarily we store the data into stage layer. And finally, we are going to persist the data into target layer. And finally, our our downstreams like consumers. Our downstreams called consumers. These consumers are finally going to use our data. So consumers like uh, data analytics team, like Power BI, QuickSight, Tableau, etc. People uses uses this tools. Target data or other people like ML people uses this target data or other people like AI people. So these BI people or data analyst people uses this data and represents this data data into dashboards or reports team. If it is machine learning and artificial intelligence people, they are going to use this target data for future predictions. So our downstreams are either data analytics team or artificial intelligence team. Okay, here we are going to implement actual transformations, actual transformations using 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 Snowflake techniques. Snowflake techniques. This is also our activity. Instead of doing transformations using Snowflake SQL, there is another technique called DBT, another tool called DBT. DBT specialized into only transformations. Except the transformations, it cannot perform any other activity. It cannot perform data ingestion. It cannot load data into Snowflake except the transformations. It performs pure transformations. So instead of writing Snowflake SQL queries to perform transformations, we are going to use DBT. DBT. So DBT stands for Data Build Tool. Data Build Tool. This data build tool specialized into transformations. Transformations. Instead of writing transformation logics using Snowflake techniques, we are going to use this DBT. Okay, let's say this DBT we can use we can use to read this raw data. To read this raw data, then we store results temporarily into this stage layer, and finally we are going to persist the results into target layer. We are going to persist the results into target layer. Target layer. So these pure transformations we can apply using DBT. Along with the DBT, there are plenty of tools available in the market, but nowadays industry giving priority or uh, more Snowflake data, Snowflake integration or Snowflake with DBT implementations are happening more. There are multiple reasons people using DBT for pure transformations. First one, it uses a pure SQL query. Second one, we use a pure select statement. Third one, learning DBT, like learning DBT nothing but learning select statement. So learning DBT is very easy. Implementing DBT is very easy. Anyone can learn and implement. Fourth one, DBT provides free and enterprise. So you can install DBT core into your developer machine. You no need to pay single rupee for development, downloading, installing, using DBT core. If it is DBT cloud, we will take a license. Both are same. There are no difference except user interface. Except user interface, the features are same. Next one thing. Along with these features, it provides a very important feature called reusability. Let's say I created one select query. I want to reuse that select query in multiple situations. We can reuse. You no need to regenerate. You can reuse. And along with this one, it also provides one powerful concept called data lineage. Let's say you applied transformations on multiple tables, and one transformation you reused in another transformation. There is a linking. Then it will provide a data flow kind of diagram. So, so it provides data flow kind of lineage graph. If any change we are applying on existed code, we can clearly know what is the impact of this change into another dependencies. So along with this one, it has CI/CD integration, like moving data from one environment to other environment, and multiple other benefits. Along with this one, it has one more benefit is once we submit the query, it converts DBT scripts into underlying data warehouse environment called Snowflake. Then submits the queries to Snowflake. Snowflake will take care to run the queries. Snowflake having powerful powerful resource we can configure using virtual warehouse concept. We can create two resources, four resources, 8 resources, 16 resources, 32 resources. We can create multiple resources to process data which is presented in Snowflake. We can use right warehouse to process your data. Let's say small data, I can use small warehouse. Medium data, I can use some medium sized warehouse. So we can create multiple warehouses, but Snowflake will not charge for all the warehouses. Only they will charge which warehouse you are using to process Snowflake data and how much time it is taken and how much data you processed. Based on that, it will generate a billing. There is a special concept, pricing of storage, pricing of this warehouse. There we are going to understand how Snowflake people calculates pricing for your Snowflake queries. Okay. Next one, along with DBT, Snowflake transformations, we can also use different technologies too, like like PySpark with Python, Python with Snowflake. Very rare cases we go this one. Only we go with data data ingestion activity purpose. This data ingestion activity purpose we use Python, but there is one technology, PySpark. PySpark can be used to implement ETL operations on top of this Snowflake. So this is also one of the most popular integration. And there is one more important component is called Snowpark. 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 So there are plenty of tools available to implement ETL operations on Snowflake. Snowflake. Okay. So here uh, industry more using Snowflake for data warehousing and DBT for transformations. DBT for transformations. You can see more jobs on these kind of combinations. Let's start in. In this session, we are going to discuss Snowflake introduction thing. So we are going to discuss Snowflake introduction. Let me explain. As part of Master Snowflake with DBT, in this session, we are going to discuss Snowflake introduction. As part of Snowflake introduction, we are going to discuss what is Snowflake, what is Snowflake, and Snowflake cloud architecture. So we are going to discuss Snowflake cloud architecture. Snowflake cloud architecture. Okay. And then prerequisites for a Snowflake. What are prerequisites for Snowflake team? So as part of today's session, we are going to discuss all these concepts today. Mm. Let's continue to first as part of Master Snowflake with DBT. In this session, we are discussing Snowflake introduction. As part of Snowflake introduction, first let's start understanding what is Snowflake. Any idea what is Snowflake? Is anyone having any idea about what is Snowflake? Yeah, correct. It is a data warehousing tool where we store huge volumes of data, collecting data from different sources, and we load the data into Snowflake environment. Yes, correct. Any other definition? Perfect. Yes, correct, correct. It is a cloud data warehousing platform and it supports unlimited storage, as you said. Yes, correct. Yeah. Uh, all the answers are correct. It is a Snowflake is a cloud-based data warehousing platform. First important point, it is a cloud-based data warehousing platform. Next one, it separates storage and processing. Let me give one more point here. Let's say if we are set up in traditional architecture, we set up like master and worker. Yes or no? Master and worker style. This worker contain storage. This worker contain processing. This worker contain storage. This worker contain processing in traditional architecture. But coming to Snowflake, it separates storage separately and processing separately because of cloud data warehousing. So most of the people think Snowflake is a cloud data warehouse. Then most of the people think Snowflake is a having its own cloud. Note it. It uses cloud services for storage and cloud services for processing. Currently, it is supporting three clouds: AWS, AWS, and Azure and GCP. Azure and GCP. Currently, Snowflake is supporting three cloud vendors. Three cloud vendors. It utilizing it utilizing features of cloud computing. So it separates both storage separately and processing separately. We will discuss what kind of service it uses in storage, what service it uses in processing. In few seconds, we are going to discuss services it used in storage, service it used in processing. Before that, let's understand one more point here. It is a scalable data storage and processing. It supports what? Scalable storage and processing. This storage, right? Backend, it uses a cloud service for storing the data. That's why there is no limit. There is no limit for your storage. You can store any size of data. Existing or traditional data warehouses having a limitation in storage. It depends upon warehouse to warehouse software. Let's say Teradata having different limitation and Vector having different limitation. So data warehouse to data warehouse, there is a limitation. But in Snowflake, there is no limitation in storage. There is no limitation in processing. Based on data you are storing into Snowflake storage, it will scale automatically. Second point, coming to processing. We can create different virtual warehouses. Processing is a generic term. Virtual warehouse is a term of Snowflake. We can create a virtual warehouse with different sizes. Let's say I can create virtual warehouse with two missions, another virtual warehouse with four missions, another virtual warehouse with eight missions. Like that, we can create multiple virtual warehouses. You may think, if I create different sizes, can Snowflake charges for that virtual warehouses? No. If you create virtual house, immediately Snowflake will not charge for that warehouse until unless you use that virtual warehouse. Let's say you used only less than a minute, then they charge for only for that time and how many virtual warehouses you use, how many missions you use. Based on that, it will calculate a charge or billing. So it never charges for multiple warehouses you created. Next, let's understand Snowflake cloud architecture. Snowflake currently supporting three cloud environments, three clouds. One is AWS, another one is Azure, and other one is GCP. So while creating Snowflake account, we can choose we can choose a cloud environment. I may like AWS, you may like Azure, and someone may like GCP. One important criteria is depends on your interested cloud, choose AWS. This is one. Second one, second scenario is depends upon the depends upon the pricing factor. That is also very important role plays in enterprise. We may think it is a dark sense sense, but when it comes monthly, that sense become $8 because Snowflake is meant for not small data. Snowflake is meant for storing a huge volumes of data. When you are dealing with the huge volume data, storage cost become huge, cost will become big, and when you process that huge volumes of data, process cost also high. So, so cost also important factor to select a cloud. Compared to AWS, Azure may be little less, GCP may be little less. Depends upon this cost factor also, people chooses corresponding backend cloud. First factor, first factor is I am a AWS client. For my all projects, I am using AWS cloud. I like AWS very much, and I ask my Snowflake team to select backend as a AWS cloud. That is one factor. Second factor is price. Price also plays very important key role. Okay. So while creating a Snowflake account, we can select a required cloud for our Snowflake backend cloud environment. Okay. Yeah. Next one thing. If I choose AWS as a cloud for my Snowflake backend, for storage purpose, it uses AWS S3 service. For processing purpose, it uses AWS EC2 missions. If I select Azure as a backend for my Snowflake, it uses Azure Blob for storage, Azure VM for processing. If I select if I select Snowflake for Snowflake backend cloud is GCP, it uses Google Cloud Storage for storage, Google Cloud Engine for Google Cloud Engine for processing team. Clear writing? Yeah. Let me add one more important point here. One more important point team. Let's say team. Let me add Snowflake Cloud architecture team. Let me add one important point. Snowflake, Snowflake Cloud, Cloud architecture. Okay. Let's say this is my Snowflake, 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 Snowflake software or Snowflake having AWS Cloud, AWS Cloud Enterprise account, Snowflake Enterprise account. Similar way, Snowflake having uh, Azure Enterprise account, Azure Enterprise account, Snowflake having GCP Enterprise, GCP Enterprise account. Okay. Let's say team here. Let's say here it uses storage and storage and processing. Let's say storage. Let's say S3 here and processing EC2, processing EC2. And similar way, if it is Azure, storage is a blob storage, and processing is Azure VM. If it is GCP, Google Cloud Storage for storage, and Cloud Engine for Google Cloud Engine for processing purpose. Here, let's say I am Akkem Sreenivas. I am creating account. So I am a Akkem Sreenivas. Okay. So I am using Snowflake URL, Snowflake URL. Then here I am creating Snowflake account. Snowflake account. I am creating Snowflake account. Then, then for me, I selected AWS as backend for Snowflake. For me, for Akkem Sreenivas, it will create a storage account. It will create compute underscore WH with minimum two resources for me. Similar way, someone created account in Snowflake, and they choose Azure. Then in their enterprise account, Blob they create a storage for you with your user, and it create multiple virtual missions in Azure, and they assign for your account. They assign for your account. Like this, based on number of users creating accounts in Snowflake, for every user, it is going to create a separate storage, separate EC2 missions for your account in their in their enterprise account. So this is complete their cloud architecture. Again, for me, I have my own account in AWS. AWS here in AWS, there are 200 plus services. I may using multiple services like S3, Glue, RDS, DynamoDB, and many more services I'm using for my application. This is my account. This AWS account is my account. When I create account in Snowflake, it is going to create accounts or these Snowflake resource and EC2 resource in their enterprise account and assigns as part of this one. Okay, clear writing? Any question here? Yeah, clear? Cloud architecture? Mm, 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 mm. No. Snowflake user interface is same, only effect is cost. Per, no. S3 bucket and everything internally taken care by the Snowflake people. You do not have option to create bucket in their enterprise account. Yeah, we can write a table, we can create a database, we can create a schema, we can create a table, we can insert the data. How they are storing internally into their enterprise is designed by their Snowflake software. They never expose how they are storing internally. So, interface is not different for backend cloud. Interface is same. Only my interest, I selected AWS. Your interest, you selected Azure. Someone interest, they selected GCP. That is one criteria. Second criteria, come to Blob, S3 is cost. To VM, EC2 is little cost. So some people chooses this backend cloud based on the cost. We have a special topic, storage cost, storage pricing. We have a special class, how Snowflake people calculate storage pricing. How Snowflake people calculates virtual virtual warehouse or processing cost. There is a special class. There you can understand differences between this AWS storage cost, Azure storage cost, GCP storage cost, and EC2 processing cost, VM processing cost, Google Cloud Engine processing cost. Correct. Correct. We do not know how they are in storing, how they are using processing. Performance wise, Same for all the clouds. Whatever the cloud you selected in the back, performance wise, everything is taken care by Snowflake software. Sure. You are again forgetting it uses only two services, S3 and EC2. If you select a AWS, it uses only two services. One is S3 and other one is EC2. Let me add one point here. I am using create table command. I am using create table command. Let's say create EMP table. In S3 location, they allocate for you, right? Here, they are going to create a folder employee for you, employee folder. Under this, if you insert data, if you insert data in employee table, it will create a file, loads the data into S3 location. If I write select query with filter conditions, select query with filter conditions, it is going to use EC2 mission to process this data. Here, any instead of writing Python software, Java software, they written this complete Snowflake software, right? It is using these resources. Usually, we write a Python software and we rely on a mission. Here, Snowflake is a software using these cloud resources instead of physical missions. Are you getting point? Hmm. Let's say, let's say example, Oracle software. Oracle software, you need a physical mission. Without a physical mission, what is the use of Oracle software? Same, here it using resources, cloud resources for uh, processing and storage. You are asking question, you are asking question. I am using Oracle software. Oracle software internally using operating system, file system, operating system, file system, okay, and it using hard disk for storage. Everything is taken by these hardware devices. What is the use of Oracle? You are asking like that. So for every storage part, processing part, complete SQL understanding, optimizing, storage techniques, everything is taken care by Oracle, right? This Oracle software designed to utilize these resources, right? Similar way, Snowflake software is designed to utilize these cloud resources. These are just services. It is using those services for storing, processing. Snowflake, perfect, correct. Virtual warehouse and databases, schemas, and everything managed by Snowflake software. Correct. Instead of physical hardware, it is using cloud resources. Clear, right? Yeah. No, it using these two services, logs it has a separate query logs. It is also internally used, but that is they are not charging for logs. Yeah. Let's understand next important point in the Snowflake introduction is prerequisites for Snowflake team. So first prerequisite is basic knowledge of computers, any computers. And next one, SQL knowledge is very, very, very important. Snowflake, to interact with the Snowflake, first we use SQL. SQL is very, very important. And next one, any cloud fundamentals knowledge. Example, why cloud fundamentals knowledge? This is my Snowflake. This is my Snowflake, and it may use as AWS, it may use as Azure, it may use as GCP, GCP. For this part, you no need to have any knowledge of cloud computing, but but to interact with different sources, let's say your source is S3, then you want to load the data from S3 to Snowflake table. You need knowledge of S3. You need knowledge of S3. Let's say you are getting data into EC2 machine, EC2 machine. So here we are getting files. In this location, we are going to install SnowSQL. Then we are going to write a SQL commands with external table concept to move local file system data to Snowflake. Snowflake. So this is uh, here you need minimum knowledge of ECL, EC2. Then to access these resources, you need IAM service. By default, AWS will not allow to access these services. You need minimum knowledge of IAM. These kind of basic knowledge of cloud. If you have three clouds basic fundamental knowledge, it's more than advantage. Any cloud knowledge is enough. Based on one cloud fundamental knowledge, we can easily explore other cloud fundamental knowledge. So that's why here, as part of Snowflake, we are going to cover SQL for Snowflake, AWS for Snowflake, and optionally any programming language, Python and Java. Here we are going to learn Python integration with Snowflake. This is not mandatory, this is optional, but these two are very, very important. We are covering SQL for Snowflake, AWS for Snowflake as part of our Snowflake with DBT course. Yeah. Let's understand it. One of our friend question is how we can handle version control system for our i- Snowflake development. Let's say we have three environments. Let's say dev environment and test environment, test environment, and then prod environment, prod environment. So version control system, any version control system nowadays most popular is Git based version control system. Most popular version control systems are Git based version control system. That's it. These are different environments. I have a Snowflake developer account. So this is my Snowflake, Snowflake, Snowflake. Here I have developer account, developer account. So developer account using Snowflake, Snowflake. web UI, web UI. I can develop queries. Let's say create a table query, insert queries, external table queries, and different procedures, and views related, and different SQL queries. I will develop. I will develop. Then finally, let's say all these queries I can place into I can place into SQL separate SQL queries, create separate, insert related separate, external related separate SQL files. These SQL files I will push into Git version control system. Git version control system. Then from this version control system, they are going to deploy into they are going to deploy into dev environment. Dev environment. Once dev unit testing is completed, they are going to move it into test environment. Once testing is completed, they are going to move it into prod environment. Prod environment. Okay. Along with this one, I said we may write multiple jobs. We may write multiple jobs. Okay. So do I need to execute these jobs manually? This is one more question one of our friend is asking. No. Here, here, data pipelines, data pipeline are data orchestration purpose, data pipeline, data orchestration purpose. Here we use Apache Airflow kind of tools. Apache Airflow, Airflow. In this Airflow, in this Airflow, there is a concept called DAG. In this DAG, we write a definition by using Snowflake connector. By using Snowflake connector. There is a connector called Snowflake connector. Using the Snowflake connector, what we are going to do? Job 1, job 1, ETL1, job 2, job 1, ETL1, job 2, ETL2, job 3, ETL3, job 4, ETL5. Like that, multiple tags I am going to define. Then I will run this tag. Development environment, I have Airflow access. Test environment, I have Airflow access. Production environment, I have Airflow access. Then I am going to run these jobs. These jobs. These jobs are going to invoke corresponding SQL file to run these environments. Clear team? Yeah. Let's start. In this session, as a part of Master Snowflake with DBT, let's start discussing DBT introduction. In this session, we are going to discuss what is DBT, why DBT, advantages of DBT, prerequisites for DBT. Okay, let's start understanding what is DBT. What is DBT? Let's say team, let's say DBT currently supporting multiple data warehouses. Currently, it is supporting PostgreSQL, Snowflake, uh, Amazon Redshift, Google BigQuery, Azure Synapse, and Azure Databricks. Currently, DBT supporting these data warehousing technologies. Okay, what is DBT here? What is the purpose of DBT? DBT is pure transformation tool. Full form of DBT is data build tool. The purpose of DBT is transformation. You may hear the term ETL. You may hear the term ETL or ELT. What is full form of ETL or ELTT? Anyone? Extract, transform, and load. In this extract and transform load, DBT works only for transform. It may be ETL architecture, it may be ELT architecture. DBT works to perform pure transformations. Except transformations, it cannot do any other activity. When we use these kind of pure transformation tools, when we use these kind of transformation tools, let me explain. Let's say, let's say we have data warehouse. We have data warehouse. So data warehouse is a place where we store history of data, where we store history of data. So we collect data from different sources, source 1, source 2, and so on, and so on, source n. From all these sources, using data ingestion technique, we will connect different sources, we will connect different data sources, then we write data into raw layer, raw layer. So we write where? Inside raw layer. And once data is collected and stored into raw layer, here on raw layer, we are going to apply transformations. For that pure transformations, we use DBT. DBT can be used to apply transformations on the data warehouses. Currently, it is supporting PostgreSQL, Amazon Redshift, Google BigQuery, okay, Azure Synapse, okay. These are Snowflake. These are currently DBT supporting. So using transformation techniques, we apply on raw data. Temporarily, we persist into stage layer. Temporarily, we persist into stage layer. Example, let's say, instead of stage layer, in, sorry, instead of stage layer, if we persist directly into target tables, let's say target tables, instead of stage layer, if we persist directly into target, let's say these target are reading by some reporting tools. These reporting tools reflecting data based on the data which is presented in target tables. Let's say instead of a stage layer, you directly persisted into target location. But the target data not proper, or it have some inconsistent data. Let's say it has some issues in the data, final output. Then that inconsistent data is reflected into reports. Then business thinks that they got these much of losses, these much of uh, uh, benefits. So they because of this misinformation, because of these reports, management team, they may think differently, they may take different decisions. So to avoid that one, first after transformation, we will persist into stage layer, then we will validate this data, whether data is generated as expected or not. If we see data is generated as expected, then we move the stage data into target layer. So clear writing. So here we are going to persist the data into target layer. This target layer data is analytical ready data. So then analytical team can use this data. They can uh, prepare reports or they can prepare dashboards using this analytical ready data. So using transformations, we are converting raw data into analytical ready data. Raw data contain different uh, formats, different style. So those are uh, clumsy, and we are doing transformations. We are making the data for analytical ready using transformations. So first point to we are connecting different sources using data ingestion techniques, and we load the data into data warehouses. Data warehouse may be Snowflake, Redshift, PostgreSQL, Azure Synapse, Google BigQuery, etc. If data is presented in these data warehouses, then again you no need of any other separate data engineering technologies to do transformations. We have a special technology called DBT. DBT specialized into pure transformations. DBT specialized into pure transformations. Okay, clear writing? Yeah. Now, now, now let's understand what is DBT. DBT is a specialized into pure transformations. It is supporting currently different data warehouses. In our course, we are going to see DBT for Snowflake. DBT for Snowflake. In DBT, we write simple SQL queries. You no need to know complex SQL queries. We use simple concept called selector. Every select is a model in DBT. Every select query is a model. We have other concepts. Later, we are going to discuss what are different other concepts are available. So we write model in DBT. Every model associated with either table or view. Model nothing but it is a simple select statement. Model nothing but simple select statement. Using DBT, what we are going to do, we will connect raw layer of Snowflake. Then we apply transformations. This transformed data, again, we are going to store it into Snowflake. So this data is presented in Snowflake. Using DBT, we read raw data, we apply transformations, then transformed data, again, we are going to load it into Snowflake. Once we loaded into target, then either data analytics team or machine learning team or artificial intelligence team reads this transformer data, then they represent in their formats. Okay, let's say how it will work. Let me diagrammatically explain. So we already know this part. We already know this part. So in first class, I have explained. Let me add briefly so that once again you will get a understanding. We may have different sources. We may have different sources using data ingestion technique like Python, PySpark, AWS Glue, AWS Glue, Azure Data Engineering, GCP Data Engineering, etc. technologies we use. We connect different data sources and we load the data into data lake. R, R. Snowflake contain Snowflake contain different features, different features like external table concept and snowpipe concept are different connectors, different connectors. Then we load the data from different sources into raw layer. Once data is loaded into raw layer, we use DBT technology to write to write queries on raw data, and we transform the data into analytical ready data. So whatever our downstreams is expecting, same format, we are going to store the data into this target location using DBT queries. Using DBT queries, we can transform raw data into analytical ready data. Clear writing? So DBT meant for implementing pure transformations. It may be ETL architecture, it may be ELT architecture. DBT specialized only into transformations. Except transformations, we cannot do any other activity. You may think, why industry going for DBT? If it is only for transformations, why industry going for DBT? If you observe nowadays, if you are using warehouses like Snowflake, Redshift, Google BigQuery, Synapse, etc., etc., if you are working on those technologies, you are suddenly seeing this one, DBT. Wherever you go, you are getting this opportunity saying people are expecting DBT. Already plenty of transformation ETL tools are available, transformation tools are available. Even warehouse having a future of snow transformation. Why industry going? Why, sorry, why industry preferring DBT for transformations? Let me explain next to screen so that it gives clear clarity. First point, first important advantage. Let's say I'm writing DBT script. I'm writing DBT script. Let's say a script. Here we are writing. Then here I created a connection to Snowflake. I created a connection to Snowflake. Later, later I removed this connection. I created connection to this Redshift. This Redshift also having same table, same style, but I transformation. You just remove this connection of Snowflake. You can give this Redshift connection. Your scripts going to work. It is not targeted to particular data warehouse. Next point. Next point. DBT, DBT, we write a code. We write a code. So that we can easily learn, easily learn, easily implement. Code, we mostly write select statement. We write select statement. In SQL, we have multiple concepts. In DBT, for transformations, we use select query. Then it is very, very easy to learn, very, very easy to implement. Advantage is easy to learn, easy to implement. Next one tip. Here, select query, let's say we call it as model, model, model. Let's say I developed a model. Then I'm writing new model. This model, I expect, this model I am implementing similar to existed model. Then I am continuing new additions. Then instead of redeveloping same logic, you can reuse this model into your new model. Reusability. Reusability. We can reuse the code any number of times, any number of location of different DBT scripts. So reusability is one more important point. Next one, I develop different models and snapshots, etc. etc. Then before handover, this is a data warehouse. Data warehouse. In this data warehouse, this is my DB name, DB1. In this we have schema 1. In that schema 1, there are 10 tables. A tester, these are 10 tables. I applied transformations and I loaded into this 10 tables. So before handovering our results to testers, we can write testing. We can write testing called unit testing, called unit testing. Unit testing. Easily we can write that unit testing. You may hear different unit testing technologies in real world. There we may write complexity or complex programmatic techniques, unit testing. But here DBT people provided different unit testing functionalities or functions. You no need manual implementations. They provided lot of functions you will get as part of DBT. You no need to write. You can just call a corresponding function so that it will validate entire row or entire column. You can pass a column or a row, then it will perform unit testing, then it will validate our input data. So unit testing is very, 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 very easy in DBT. Next thing. Once I developed a DBT script 1, script 2, script 3. This is my developer mission. In developer mission, I developed multiple DBT scripts. Let's say multiple DBT scripts. Then you can push this code into any repository like Git-based version control system. You can push your code to any version control system. Then DevOps people writes Jenkins jobs. This Jenkins job going to read either GitHub Actions or Jenkins job. Then this is going to move your data to dev server. Once dev server, if you check unit testing, then they move to testing server. Once testers says confirmation, every function are working properly, then it moves to live. It moves to live. Easy integration with CI/CD pipelines. Deployment is very, very easy. Okay, let's say I developed 100 DBT scripts to implement 100 types of transformations. everything's completed. We deployed into production server, and production server is running fine. One fine day, one special person of our application, he applies different approaches, different combinations. Then application fails to generate accurate result. Yes or no? Then, then we want to analysis what happened, what went wrong. Let's say today you developed. After 1 year, you may not give 100% guarantee. After 1 year or after 1 month, after 2 months, you may not give guarantee you will work forever in that company. Yes, sir. Then new person is entered and he is trying to fix the issue. He is not understanding at a time. He is taking longer time to understand this DBT scripts. So instead, if you write a documentation for every functionality, let's say job one, what is happening? What are functions you created? What are different variables you created? What is the purpose you created a function? What is the purpose you created variables, etc. Such kind of documentation we can easily generate using document feature of DBT. Okay. Next one thing. It is free. DBT comes into two flavors. DBT core, DBT core, and DBT cloud. DBT core and DBT cloud. DBT core is completely free. It is completely free. You no need to pay single rupee for downloading, installing, using DBT core. But DBT cloud, you will get a earlier 30 days. Nowadays they reduced different uh, date. Earlier it was 30 days. Now it reduced to 15 days too. So every time you can create a new account, then you can attach that account to Snowflake. This is one complexity if you go with DBT cloud. But DBT cloud core is completely free. You no need to pay single rupee for DBT core. You can download, install DBT core. It's completely free. Yeah, yeah. Mm, no, no, it's wrong. It's wrong. Both are using. Let's say only one difference you can see user interface. Except user interface, there is no difference between DBT core and DBT cloud. Whatever you can do with the DBT cloud, same thing you can achieve with DBT core. Both are same. But approach of development. Here we use VS Code for developing DBT script. Here they provide nice user interface, integrating with CI/CD and integrating with the Snowflake. You can see nice user interface. Correct, correct. Actual user interface. But here, everything you have to write in configurations and then you have to write in scripts. Here also we write a script, but nice user interface called graphical user interface. You are correct. Additionally, you will get additional benefits, but Here we have to do everything manually. Other than that, there is no other difference. While, yeah, let me have one point. After that, you can read. I am going to show first DBT Cloud. Later, I am going to show same examples with DBT Core. Then, you get a clear clarity. First point. Second point. I do not want to pay money. I want to pure transformation implementation. Finally, finally, how these scripts are going to execute, where it is going to execute, you will get that clarity. You will understand what is the use of cloud, what is the use of core. These DBT scripts are going to execute. If DBT clouds any runtime environment, then we will prefer DBT cloud. So there is one important point is once we develop a DBT script, once we submit a DBT script, these DBT scripts runs inside our data warehouse server. We do not require a separate environment to run DBT scripts. We do not require, whether it may be DBT core, whether it may be DBT cloud, we do not require a separate environment. Once we submit DBT queries, these DBT queries are submitted to supported data warehousing technologies. I already explained DBT currently supporting these data warehouses. Once we submit, once we run this DBT script through the connection, it goes to corresponding data warehouse, and this data warehouse is responsible to run this DBT scripts. Okay. Yeah. Now tell me. Any, I think someone is to ask question. Yeah. He said one important point here. Let's say it may be DBT core, it may be DBT cloud. We write a script. This script we push into Git based version control system. Any version control system, let's say Git based version control system. Then DevOps team, DevOps team, they are going to deploy the scripts into dev environment. So as a developer, we create a feature branch, right? We create a feature branch. In this feature branch, we save our queries, save our script. Once we feel this script is successfully completed, then we merge the script to master branch or developer branch. Once we merge, DevOps people going to move this one to dev environment. Once dev unit testing is completed, they are going to move to test environment. Once it is completed, they are going to move to prod environment. This is same as regular application style. We are going to push our code to version control system. Clear? Yeah. Next point to do. Next point here. Let me add one important point of why DBT and advantage of DBT. There is one more feature is pending, that is data lineage graph. Data lineage graph. You may hear diagram, data flow diagrams. You may see data flow. So if you create models, I created model 1 and I used this model 1 into model 2 and I used model 2 into model 3. So if you create any linking of one model, any reusability in one model into another model, Then what DBT going to prefer? It is going to prefer a lineage graph. Lineage graph. Let's say once we deploy this all DBT scripts, our client is asking, saying, "Hey Srinivas, I want to add new feature called X. I want to add new feature called X into this model 1. I want to add X feature into model 1. Then by this data lineage graph, I can say if I do this modification on model M1, then this is the impact of these two models. It will impact these two models. I can analyze, I can update to my client. Then if client says proceed, if client says proceed, then I can modify. If client says wait for approval, then we will wait for approval. Then we will, once approval comes, then we will continue that modifications. Otherwise, we will stop. So these kind of lineage graphs we can see are in our DBT implementation. Once you submit, it will prepare a lineage graph. By seeing this lineage graph, we can update our client if there is any changes required. This is the impact. These many impacts with this change. We can give this clear picture to client. So, clear item. These are different advantages. And next one, if you want to learn DBT, what are prerequisites? First prerequisite is SQL tip. SQL. In that SQL, you just need to know select statement. Learning select statement is very easy. Yes or no? And any data warehousing knowledge. In this example, we need knowledge of Snowflake. We are working for Snowflake, right? Then we need knowledge of Snowflake. That's why first we will learn Snowflake. Next we will learn DBT. Let's say if you are directly started DBT, then you already know Snowflake. Otherwise, first you have to complete Snowflake, then you can continue DBT. And you may ask one more question. How much level of Snowflake knowledge is required? I would say basic fundamental knowledge is more than enough for learning DBT. For cracking Snowflake with DBT developer job, you need complete knowledge of Snowflake, but working DBT with Snowflake, fundamental knowledge of Snowflake is more than enough. Let's say I started Snowflake a week back. That 1 week knowledge is more than to start parallelly DBT. In DBT, we write simple select statement. Instead of simple, let's say we use select statement to implement DBT jobs. Learning select statement, converting to DBT scripts, very easy. Okay, clear writing? Let me